On and go.
Welcome to yet another episode of Indigenization Appreciation Hour. I'm Saurav Jha, and with me is my long-term associate Sriram Tyagarajan. And this is going to be another artillery-centric episode. Although we are going to talk much more about artillery in this episode and less about tube artillery. There might be a few questions from the last episode which have carried over to this one. We'll try to answer those, although those relate more to tube artillery than anything else. So, as you know, rocket artillery is an area where India has also experienced success as far as indigenous development is concerned. Success to the extent that we've also exported systems to other countries, and we might even be in the process of exporting systems to Western Europe, for all you know. Right. One is, of course, talking about the Pinaka multi-launch rocket system. Because although, earlier we used to call it the multi-barrel rocket system because we had the Grad for the longest time. But the Pinaka is more of an MLRS. For instance, it is a podded system, right? You can switch, you can reload much more quickly. And the podded system also allows you to have different kinds of pods, I mean, different rockets of different caliber on the same launcher. You don't really need to change the launcher much at all to achieve that kind of a swap. So, in that sense, it is more of a multi-launch rocket system and an Indian equivalent to somebody saying the voice isn't clear. Let me just. Can you hear me now? Is the voice
Yeah.
clear? Okay. So it's a multi-launch rocket system and it is quite contemporary as it were, and it has clearly evolved over time. It has evolved quite a bit over time. We started off with the Pinaka Mark 1 rockets which had a range of 37.5 kilometers, and even with the trajectory correction system which was imported, it was still very much an area weapon. Over time, of course, the system has evolved, and now we have guided munitions that have been tested and are basically being cleared for production also. From the one is of course talking about the guided Pinaka, and there'll be a guided Pinaka ER as well, and there is the long range guided rocket which was also put on display recently in that exposition in Hyderabad, which we'll show pictures of. So this is a fairly versatile system, and it's a highly contemporary. I mean, it's a highly modern system, as it were, right? You can sort of the entire in the case of the Pinaka Mark One, in the case of the 214 millimeter rockets, right? You can sort of unleash 72 rockets in about 44 seconds. That's quite good, and this is of course from that expo that I was talking about. So you can see that there are three types of rockets displayed over here. At the very back is of course the guided Pinaka. Somebody is the audio has the audio stopped again? Pinaka, can you hear me? Is the audio?
No, no, no. The audio is fine.
Yeah. Okay. So the thing is that there's a anyway. I don't know why some people keep saying the audio stopped and all, but whatever. So there's the guided Pinaka at the back. Now that has a range of 75 kilometers, right? There have been you would have seen reportage saying that it was tested out to 90 kilometers. Also, it has a certain CEP, but which is fairly good for the system. Let's not go by what has been discussed. In the middle, you can see the Pinaka Mark 1 enhanced artillery rocket, which is also called the EPRS. That has a range of up to 50 kilometers. And of course, that has also certain changes have been made between just the garden variety Pinaka Mark 1 and this. Those changes are actually important because after all, we have a lot of geeks here, so they'll like to hear it. See, the Pinaka Mark 1 enhanced, right? It has a the igniter is mounted on the closing cap, unlike the head end igniter that you have in the Pinaka Mark 1 system, right? So this can be easily removed, you can easily replace it, life extension is much easier. In any case, note one thing you should note is that if the rocket's igniter, the ignition system, is mounted in the nozzle throat, then it can be jettisoned in the course of flight, and the rocket does not have to carry dead weight load. This is the case with the Pinaka Mark. This is the case with the guided Pinaka, by the way, and this has contributed to the enhancement of range, as you see. See, the guided Pinaka is nothing but is basically derived from the Pinaka Mark II only. You can see that the specs are very similar. But the one of the reasons why, I mean, the Pinaka Mark II also has a nozzle and igniter only, nozzle throat ignite. The ignition system is based in the nozzle throat, but this has contributed. There are other improvements that have also been made in the casing itself, right? So those improvements have contributed to achieving a higher range. And of course, it's a guided system. It has an inertial navigation system. It doesn't have a front end seeker or something that would make it something else altogether. But and it's way cheaper than the its equivalents. So in the case the equivalent to the guided Pinaka would, in the case of the Americans, would be the M30 series of rockets, right? Compatible with both the HIMARS and the HIMARS or HIMARS, whatever you want to call it, and the M270 that came before it. The third thing, if you can, Shriram, if you would go back to that picture again, the third thing is the most interesting thing, though. That
This
one that
one,
has those,
the
yeah, the rockets on
comparison
display.
chart.
Yeah, no, the one before that. Just the three rockets on display from the Hyderabad Expo.
Ah, okay. Yeah, go ahead. I'll switch it.
Yeah. So yeah. So the third thing over there was, of course, the long range, what is called the long range guided rocket. It's obviously its diameter
Fatter.
is much greater than 214 millimeter, and that thing seems to be good enough for anything between 120 to 150 kilometers is what I would say. Incidentally, I had discussed about such a system with a former chairman of DRDO when when we had conducted a long interview with him, and this has been in the works for a while. But I guess, there's been some doctrinal thinking behind the shift, which has led to it finally being realized, is my surmise. I will not say it with a mark of authority or anything, but it could be, because this was in the works. This has been in the works for a long time. And obviously this is also a guided system. As you can see, it has peculiar control surfaces, etc., etc. So what we are seeing here is the larger point that we would like to make, is that this is what happens when you stick with the program. Okay, what you're seeing here is the decided is the steady evolution of a system to such a point that now it can possibly be a world beater even in the export market, right? Because Armenia has imported this system, and Armenia, as has been reported, has imported the guided Pinaka also along with it. And of course, there is a DAC clearance for a certain number of guided Pinaka units as well. So what you're seeing is what happens when you stick with something and you work on it and you embrace spiral development. And the indigenous content levels of the Pinaka MLRS are also going up over time. Right, there was a time when the roller rings, all kinds of sub components and important parts were basically imported. But as you are seeing, as the numbers have gone up from the first initial two regiments to then another two were ordered, and now six further are on order and are being built right now. Indigenous content levels are also going up commensurately with time. So that is the other thing. If you stick with something and if you then order it in the right kind of quantities, we keep talking about minimum order quantities, then you will see a decided shift in the composition of the program itself. That is what I would like to say. Sriram has a lot to say about this point, I think. So I'll sort of hand it over to him now. He
Yeah.
can take you through his views on the matter.
No, I'll just continue on what you said. See, initial orders way back in 2010 were for two regiments. A regiment has 18 launchers and times 6
Hmm.
rockets with how many ever reloads are ordered. So the first two regiments were placed, the orders were placed way back, and they were executed. And then there was an order for four more regiments, and then um, an order for six more. Just 1 second, please. So, so six more, and then now we have a large order, and in the meanwhile, we have a private sector company who's doing the propellants for the Pinaka rockets, and they were able to come up and say we will build the whole thing. Sorry about that. Yeah. So Solar was making the propellants for the Pinaka rockets, and they said, why can't we do the whole thing? And they came up and said, fine, let's just get into making the whole rockets themselves. And see, this is from way back, and they didn't just do the Pinaka, but they did the Akash propellants also. This is what goes inside the metal tubes that you see outside, right? This is the propellant which is there inside, and the shape of the orifice within is determined by the burn rates and the material and what the designers want the flight profile to be and speed profile to be. We'll talk about this on another episode if we ever talk about our strategic systems. But anyway, coming back to orders. So once you have 4 regiments, 6 regiments, and now a gigantic order this year, what happens is such companies are then confident of some return on investment if they actually put in the money to expand their facilities, create newer versions, or let's say put in the effort to join the program more enthusiastically and do things on their own, be it wanting to produce more subsystems of the whole program or create variations of the same thing on their own, or enhance production means, or even provide design improvements. See, over a long period of any product development, this is what happens, where you keep making something, you find out where things can be improved, you get back to the design agency and tell them, see, in the process of manufacturing, we find that this can be made better. Some parts can be designed better so that it gets manufactured easier, or the costs can be lowered because we can manufacture this in a more efficient manner, or getting raw materials in a particular size makes it cheaper for us to manufacture it, and pass it on to the end customer, bringing it, bringing the overall cost down. And obviously, like I'm sure everybody has studied a little bit of economics, right? The bigger your order quantity, the greater discount you get. So as you keep making rockets in the hundreds now, compared to the first 2 regiment order. Now, if you have a 6 regiment order, so that's 6 into 18 times 6 at the minimum, right? Number of rockets. Assume at least 1 reload.
Into 12.
Yeah, sorry, 12. 2 points of 6. Yeah. 12 and times the number of reloads that the user has planned for and whatever is sanctioned, right? So assume even 1:1 replacement, that is still times 2. So you have a giant number. So 6 times 18 times 12 times 2. It runs in the hundreds. And see, it's not just the rockets themselves. There is the electronics component which somebody will have to make. There is the truck, right? So a regiment is 18 trucks, and then there is a reload truck, right? Somebody has to make that, be it Bemel or L&T or Tata. They've made launchers for the Pinaka program, as well as all our surface-to-air missile programs, and even the Grad, upgrade program. So you're parceling out business to all of these companies, even if one of the erstwhile OFB companies, Yantra or MIL, who's going to be the lead integrator, they will again have to subcontract out all of the other components to these companies. So again, you're spending your own money in the country and having a multiplier effect within the country, because part of that money will again be subcontracted within the country. Multiplier effect, rather than sending the whole thing outside and having no significant, let's say, accretion to GDP. Anyway, coming back to the types of rockets that we have. The other thing that now that we seem to have some momentum, and remember the Pinaka Mark II was supposed to be an enhancement or a replacement for the Pinakas already in production. So not only are we getting a better version of the Pinaka, we also have not exactly placed orders for the guided version, right? So the guided version, the 300 LRGR, which are going to get into testing soon, will also get orders. Now, all of these, the army has an existing setup for tube and rocket artillery. So now, when all of these get into production, I'm sure, given that it is being split between two production agencies for different versions, they should be getting inducted in parallel, and within a few, let's say 2-3 years max, because I think the guided version is already ready. So then once we have orders for these, we'd have further numbers getting inducted into the army. So compared to an anemic Smerch and Grad position with the army, we now have enhanced the rocket, the beginnings of a really solid rocket force with the army. And all of this should be inducted within this decade. The Pinaka orders which have been given this year, which they should be executed within 5 years easily. And again, if it's a similar number, or maybe given that guided might cost higher per round, we might have let's say a smaller order quantity, or maybe not. We never know what the thinking is in the near future. So if we have an equal order number, then again, even that can be easily executed within another 2-3 years from order date, assuming files move through the MOD bureaucracy and the whole sanctioning process happens quickly. So we're looking at a time frame of 8 to 10 years where we can have significant rocket artillery numbers. Even if we consider the unstated deadline of 2027, 28, we can still have another 4 to 6 regiments easily, right? Depending on how production goes. And again, if the same companies are asked for more, I'm sure they can rush production, because like Saurav was just talking about the indigenous content, right? That can be increased, or we can find workarounds if we need to push production, and the imported components have to be figured out when it comes to increasing production. But see, that's not the only let's say force multiplier on the ground. We also have a lot of Indian companies who are coming up with such rocket artillery pod delivered UAVs. So those can also be another reload, so to speak, or an alternate munition, an alternate rocket, if you want to call it, that can be launched from the same launcher, from the same pods. So any of these UAVs can also be considered to be an alternate to an artillery, the conventional tube and rocket artillery vector, where the range is much larger. The max that ATAGS is able to reach is just under 50 kilometers in the planes at sea level. So a UAV can hit 50 or hit 500 kilometers, and it comes down to the size of the UAV itself. So we have these options. So once you have all of these launches ready, we have 2 plus 4 plus 6, let's say 10 regiments, right? 12 regiments. So out of 12 regiments, you have times 18 launchers. Even if you take one regiment out of it and say you can have UAV launchers out of it, you can have significant reach and with mass. So as far as numbers and the capability built up in this particular arena is concerned, I think we are on the right track. We would still like double the numbers, but I think compared to what we get in other areas, we're good.
See, taking up on that, it's like this, okay? If you look at things like roller screws, slewing ring, bearings, VT fuses, these have all been progressively indigenized. And as the numbers have gone up, you can source them from domestic industry also, right? Now, the other thing is that the focus, as we talked about the numbers, the numbers are there is a DAC clearance for a certain number of guided pinakas, right? Guided pinaka rocket, the 75-kilometer range guided round. LRGR is still in development, as we know, right? The much fatter, sort of larger diameter rocket, and the focus is the production rate is of course in the thousands, and there is more than one supplier now, right? There's a private sector supplier, there's a public sector supplier. Who was the public sector supplier was there earlier, has this pedigree of making rockets for both the Grad and the Smirch, right? So, and then of course you have a private sector supplier as well. So the numbers are there, and the numbers are going to be in the tens of thousands ultimately, nothing less than that. The orders that you saw recently for the ADM Type 2 munitions, right? And the ADM Type 2 is nothing but what is called a DPICM, dual purpose improved conventional munition, right? So it has both shape charges as well as fragmentation in it. So it has a both an anti-tank role, an anti-armor role, and an anti personnel role. And there is an ADM Type 3 also. The difference between ADM Type 2 and Type 3 remains in how many submunitions you have, basically. The layers may be this, there may be more layers in one than the other, and there'll be a certain number of submunitions per layer. So that is how it goes. There'll be other improvements. All of these also have what is called an FSLC, essentially. Each of these has an FSLC, which is just a flexible liner shaped charge, which is coupled with the spring based force ejection mechanism. That is how you disperse the submunitions, essentially. So these are also, while these may not seem like things which are very great or anything, but they are actually small things that matter a lot, and they have been worked upon. They have been assiduously worked upon. So Shriram has put up an image of the guided Pinaka and the various components that you have, right? You have the actuator bay, the GPS bay. So as you can see, it has an INS system which can receive satellite updates, right? And the guided Pinaka as of 2020 is almost half the cost of the equivalent GMLRS from USA. The M30 series of munitions. So it's basically almost half the cost, and this would have gone up by now. And with rate production in India, this would probably stay at where it is. So you have, but one thing we must remember, that the GMLRS, if you go by numbers from 2021, the production orders, it has been for 50,000 units. Okay, so that's how seriously the Americans take their rocket artillery. I mean, I don't know what our I won't let's not get into exactly what our production numbers will be for the guided Pinaka, but it should also rise over time. I mean, we should not only look at the Pinaka as an area weapon, because what we've seen in the Ukrainian conflict is that precision matters. Get a, hitting the enemy in the open matters, and causing maximum damage matters now, more than just suppressive fire or general suppression over an area, etc., and all that. So the counter battery fire is also no longer a 27-kilometer game. Okay, counter battery fire can come from hundreds of kilometers away also, if you're found out in the open, right? So you've seen how Smirch and other, and even how Iskandars have been caught out in the open, Iskandar launchers, by American supplied ATACMs in the Russo-Ukraine war. So that is the world that we are in right now. So the focus will also have to be on the guided Pinaka system as we go forward, and on the LRGR, which is very important. Now there is this question of whether this will be a part of the rocket force or not. See, anything which is hitting targets 120 kilometers away will probably not be a part of the rocket force, in my view. What is usually a part of why is something assigned to something, to a particular formation? If something is assigned to a core level formation, say in the Indian Army, it means, I'm talking about a long range vector. It means that the assets required for the kill chain, for the RSTA, related to that particular munition, and that particular vector, is available only at the core level. You can hit only what you can see, right? Somebody further down the chain is not really in a position to manage an UDA cycle to prosecute a target far away. But this concept is also changing over time, because in the as things go by, it's going to be more of a mesh, right? You are going to have a network mesh, and the inputs may come from somewhere and somebody else who may just be pulling the trigger somewhere else. That is how things are evolving. That is already happening in the Ukraine conflict. So even these issues of, whether this is a core level asset, a divisional asset, or a brigade level asset, these are also questions which are in the flux right now. But having said that, the integrated rocket force is likely to be comprised by systems which are longer range than just the guided Pinaka or even the LRGR. Probably things that are, what is called operational range beyond 300 kilometers. That is what is going to go to the integrated rocket force. So that is what is going to happen. Now, I think you had, Sriram, I think you had a point to make about the guided Pinaka also, because you have seen it up close and personal in several, expositions and stuff like that. So, why don't you take us a bit through its, elements, its components?
Sure. I mean, uh, for any guided system or precision guided system, you need something which does the computing. First, there's a sensor which obtains accurate location data, and then you have a computer which compares it with where it should be, and then the computer then actuates a fin or any kind of thrust vector system, and those are the fins, right? So, and these are your uh, let's say basics of any precision guiding uh, system. So as you can see, you have a GPS bay. GPS is kind of a placeholder name when it comes to any of the Indian precision guided programs. We tend to use GPS, GLONASS, and INS together, and then we have electromechanical actuators. These are incredibly uh, tough to obtain. Some of them are still ITARD and technology denied, even completed products because of what they go into, right? So precision guidance kits for bombs and rocket artillery like this. So obviously the people who have this capability do not sell it at least that easily. So electromechanical actuator is just a motor with limbs which can change the way the fins are, right? The angle of the fins. As you can see, there are 4 fins. So one motor drives all 4, where you can change the deflection of the fins so that the rocket itself moves while it's in the air, so that it can correct its trajectory and hits the target. So RCI, right? Research Center for Remarket. So they have been at the forefront of making these actuators from hydraulic to pneumatic to
EMAs,
electromechanical today.
EHSVs, all.
Yeah.
Absolutely.
Right. So, and you can imagine these are really important for strategic missiles. So, this is why it is their forte, right? They've been working on this from the IGM-DP times, and they've obviously had to work on the really big ones for the ballistic missiles and the small ones for the NAG, obviously for ages. Right. So again, so the GPS, GNSS, GLONASS, Gagan, whatever, right? So those sensors need to be made, and then you have compute. So compute is never an issue because no matter what you base it on, even if you call it an imported subsystem, right? The PCB, the electronics that go into it, these are all not contemporary when it comes to normal regular civilian use. You don't have the latest AMD or an Intel CPU on those. You don't need them, right? So it can be something that is 20 years old, as long as it is proven and has a vast availability. Availability is not an issue. You can source it from anywhere, even within the country. You can just go tear up old PCs that get sold off by government departments or somebody, or even schools for that matter, right? And you can plug and play. Same goes for other chips. This isn't as compute, let's say, demanding as running image matching, right? So DSMAC or something. So even those don't require too much. We're not doing EW signature matching on the fly on a radar or an EW system, which needs something extremely fast, like a current day FPGA, right? Like the Vertex from Xilinx. These do not need something that much, but they still require some capability in trajectory correction. You need a lot of testing within the lab at subsystem level. Then you have to test it with hardware in loop systems in your lab, and obviously build it and put it on a rocket and test it. I think there were 25 test firings, if I'm not wrong, of the guide at Pinaka sometime in 2022, if I'm not wrong. All up tests, right? So all of this needs to be made, and we all have swap concerns no matter what we build, right? So it has to have a certain limited amount of battery. Weight is a concern. The actuators are a concern. The Pinaka flies Mach 1 plus, so it needs to work at those speeds, and how much it corrects, the logic that is built into it. It's almost like a precision guided bomb. So the same logic holds, right?
No,
so you have to correct.
It's more complex than a precision guided bomb. I'll just interrupt you there.
Yeah,
Right,
I don't know what the terminal speed is for PG bombs, but this thing does fly Mach 1 plus. So I mean, they released 0.8 Mach from planes, the precision guided bombs.
Yeah.
So once do they pick up speed? Do they cross supersonic? I'm not sure. Maybe they do. We'll have to look that up. If somebody knows, please, you can add that in the comments. So anyway, coming back to this, so you have to do a couple of things, right? One is your range correction, and another is your azimuth correction. So you can either go long or short, or you can go left or right. So both of these need to be corrected. If people remember, we have an IDEX PGK program for mortars as well as artillery shells. Zeus Numerics and some other company are part of it. So they are handling, right, at first level, just range correction, where the muzzle velocity radar has data on the speed, and the other wind data comes from the wind profiler sensors that are set up next to the artillery gun. So this data gets sent to the shell immediately after getting fired, and then the PGK inside, the logic inside, then corrects range using all of this and predetermined logic. So, and right now we're at range correction. So range and azimuth in such a small form factor, right? At least the rocket is pretty huge. The artillery shell nose cone is pretty small. Anybody who's seen one in person would know. Even the dummy inert ones at the expos and shows and army days and all. If you look at them, the nose cone is pretty small, and be it a tank gun or an artillery shell, there is immense acceleration when the gun is fired. Something like 50 G, if I'm not wrong, for a tank gun. I'm sure it is somewhere similar to the same thing for an artillery gun. I know I'm rambling, but let me just finish, right? So all of this electronics needs to be mechanically stable to take something, that violent. I mean, rocket launch is easier, it's smoother, you can tailor the grain and all of that.
No,
but coming back to this,
artillery gun would be thousands of Gs. And artillery,
sorry, I might be quoting it wrong. I'll look it up and let you guys know. But for a rocket, then you would have all of these systems working together. So, and all of this is done in-house in India, right? So the entire PGK kit was, the prototype initially was made using imported components, but now it is predominantly indigenous. The electronics come from outside, but yeah, that will have to wait for a few years to fix. But now we have proved it, and it is ready. So we'll now wait for orders, and now the question now then comes to guidance and cost. Like we see, it's projected at 78 lakhs. This is 2020 cost. We are 5 years down the line now. Maybe if we order it in enough numbers, as Saurav says, we might get back to that cost. Maybe let's take it as 100, right, per round. Even that is not too bad.
Yeah,
And
well,
the
see,
CEP,
yeah, go ahead,
one
go ahead.
sec, sorry. Yeah, the CEP is less than 40. So for a area denial munition or a pre-formed warhead, that might not be too bad because you're still sending multiple rounds. It's not just one.
See, Sriram, don't discount the unsung hero in all of this, okay? Which is the indigenously developed ET fuse, right? Without that ET fuse, you're not going to be able to deploy DPICM anyway, right? Because you
Yeah.
need multiple electrical pulses. You need to initiate a whole bunch of squibs to have those detonate at a particular time, so that the FSC leads to the ejection of the submunitions. So the ET fuse is a core component, and you need to master the ET fuses components also. You need to have the thermal battery for it. Such fuses, obviously they'll have a turbo generator. The VT fuse won't cut it when you talk about something that is deploying submunitions. So that has been developed indigenously also. So that
Yeah.
is
So
something that,
just to
yeah,
jump in, VT and
yeah.
ET, right?
Hmm.
So can you just clarify what those are?
Yeah, so VT is basically an electronic time fuse, right? And VT is nothing but a variable time
Variable
fuse.
time.
So yeah. So if you have something like a prefragment, even if you have just a pure prefragmented water RHE warhead, you can do it with a VT sort of fuse. But if you want to deploy these submunitions, then you need an ET fuse. You won't be able to do it with the standard, legacy VT fuse or anything. There are DASD fuses also, which have been developed and stuff like that. Of course, now I am going to begin to ramble if I get into all this, so I won't. But the points that you made is very important, and I think you wanted to say 50,000 Gs, right? Because that is
Yeah.
the kind of
Sorry. Yeah.
50. That is the kind of shock that a shell experiences from an artillery 155 millimeter artillery gun. So obviously, you have to your electronics. If you want to have a guided round, as you clearly spelled out just a few minutes ago, your electronics will have to withstand that kind of shock, and that in itself is a challenge, right? It's a major challenge. But these are things that can now be done in India and are being done in India. Course correcting fuses are also being developed in India, right? You may not do, which is a cheaper option as compared to having an all up guided round, or even
Like the
having a front,
Excalibur.
yeah, like the Excalibur. So obviously the accuracy won't be the same, but it'll be good enough. Because if you can, there's always that trade off between numbers and guidance packages. So course correcting fuse might be in some kind of a sweet spot when you talk about that, as far as 155 millimeter artillery shells is concerned. So I'll just take a couple of questions that people had earlier, and then we'll go to other topics. So Akshay Iyer had a question. Thank you for your contribution. Can we have a sub-base rocket force cheap and more? Sub-base as in so you will have SSGNs then, basically. If you want to have enough number of munitions on board a submarine, then these diesel electric boats won't cut it. And having a VLS on a diesel electric boat is not the greatest idea. You'll need a large SSGN, and you'll have to have a whole bunch of VLS on it. And those VLS should be able to pack a whole bunch of cruise missiles or hypersonic strike systems, as the case may be. So you could move in that direction. The Ramu, who's made another contribution, thank you for that. What happened near the China border with our UAV? Well, you have the army statement on it. The army says that there was no electronic interference or cyber sort of exploitation that led to the downing of the drone. So we'll have to go by what the army says, I guess, on this matter. But I can say one thing, that the world over, as you know, if you would remember, the Iranians managed to spoof, an RQ-170 itself, and that had to land on Iranian soil. There have been instances of drones being spoofed. There have been instances of cyber exploits. There have been instances where backdoors have been found, where in a so-called indigenous drone,
Yeah, I have the picture.
the thing has
The
been pre.
Iranians released. Hmm?
Yeah, that's the
That's the one.
RQ-170 right there. So that is from way back in the 2010s. So that has happened. That sort of thing has happened. So it's not out of the realm of possibility. As far as this specific incident is concerned, let's go by what the army is saying. If they believe that no such thing happened, we'll go by that. So that is where we'll keep that matter. On another matter is Rakesh has a whole bunch of comments. He says a better comparison would be PHL 16 and K239. No, actually, HIMARS is a good comparison to the Pinaka. I would continue to maintain that. And he's asking, is the rocket force even happening? We better all pray that it is happening because if it isn't, then
Nee,
things
but
are, yeah.
Ajit Dubey of ANI did say that Pralay orders are happening, and that would form a part of the rocket force.
Yeah, we've seen orders like I think the total Pralay orders between the army and air force, if you go by reporting, is around 370 at the moment, right? 250 and 120 there. The thing is that first of all, production numbers need to be boosted. So these chup change orders of 100, 270 will not work. We know how many Iskandars have been used by the Russians. We know how many DF-16s, DF-15s, and now DF-12s are going to be there in the inventory of the People's Liberation Army rocket force. Right? We need to stop kidding ourselves. We need these systems in the thousands for modern day war. Right? And your planes are not always going to be available to prosecute targets. You will need this rocket force. This rocket force is the way ahead, and you must present the enemy with a really problematic challenge, right? The enemy will get stretched trying to invest in air and missile defenses. So that is how it has to go. And something like the Pralay is an extremely modern system. It is contemporary. It can come in different warhead configurations. Like it has it can be it is a it's a, I mean, it has a guidance package. So all of it is. But we are talking about something which is very useful given what we've seen in the wars of the recent past. And so we need to now move forward on this in a decided manner. I've used this word a few times in today's episode, but I think the occasion calls for it, perhaps. What do you think, Sriram? Would you agree with what I'm saying?
Absolutely. I mean, see, we come back to the same thing that we started off the episode with: numbers, numbers, numbers. You provide
Yeah.
numbers, people will bring up solutions using existing production capability, the variants, new products on their own, because they have a steady stream of income, and they can actually use some of the profits to give it to a couple of idiots and say, come up with something new, come up with something wacky, right? Come up with something new. So, see, there's an old Vivekananda quote, I'm sure you know it, but see, you need food in the stomach first. So everybody targeting Indian companies for wanting JVs with foreign OEMs, because that gives them an assured, income compared to, becoming a DCPP and not knowing whether a particular product that has been developed will get orders in the next 5 or 10 years. That kind of uncertainty, private sector cannot function with. You can have DPSUs with a production line lying idle for years. That will not happen with the private sector, right? They need to pay salaries. The government can keep paying salaries even without a production line churning out anything. Anyway, yeah, that is my view, right? Trying to be as politically correct as possible while not being. Okay, this is something that I was talking
Yeah.
about earlier.
Go ahead.
Aditya has very kindly sent me a link. So this is from an IDEX challenge.
God bless
Uh,
Aditya.
yeah. So this is a loiter munition, that is launchable from a Pinaka pod or Grados much, right? As the description says, so right? MB LM system. So it says, capability launch 10 or more in a salvo mode, anti-jammer, GPS EOIR, long range data communication, and then extended range up to 500 kilometers with SAT based C2. So, like I said, we were talking about 40 kilometers, 50 kilometers for traditional rocket and tube launched artillery, right? So you put a loitering munition inside and you get 12 loitering munitions that can hit up to 500 kilometers. Now it comes under your rocket force classification. So you can call it dual use in the non-nuclear, phraseology, if you want to call it that way. But See, something like a Pinaka pod can be used to target 45 kilometers all the way to 500. So, would you call it rocket force then, or would you still call it, division
No,
level,
if
core
you want,
level asset?
if you want to be really facetious, it would be there'll be two phones over there. Okay, so one phone would say, "Okay, I'm right now in part of the artillery corps only." Because I'm prosecuting targets. Suddenly, the other phone will ring. Okay, you've just been, reassigned to something called the
Yeah,
rocket
but
force, the
see,
integrated
this
rocket
is
force.
another very important thing where we're talking about shortening kill chains. This is something that the Americans keep talking about. I want to hit something within 5 minutes of identifying a target.
Yeah, 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 yeah.
Right. So, and this is something the army is also aware of,
But
and they're
but
trying to
Sriram,
shorten
in the
that time.
case in the case of 155 millimeter artillery, it's already 1 to 2 minutes the targeting cycle. It's
Huh.
not 8 or 9 minutes as it used to
Because
be.
we've had FAOs, right, forward
Yeah,
observers who can do this, and now you
yeah,
have
for
artillery having embedded UAV based observers, right? They have a name for it. I forgot. But
yeah, tactical air control, by air controller, forward artillery controller.
huh.
That's what used to be. Yeah.
So
Uh,
now they have their own forward observation. Let's call them agents, right? So you can still hit 500 kilometers would be non-line of sight. So then you would have aerial assets, maybe even space assets that you need to get in touch with, and yeah, but that would still be a higher level
but yeah,
decision.
but like in the case of the Americans, the national technical means is very much going to be part of the artillery kill chain, right? National technical means are going to be used. Various levels of airborne ISR assets will be in play. So the whole proposition is ultimately a little on the expensive side. But if you don't do it today, then you're kidding yourself. Like I said, you have to do it because it's a matter of national security, and this is something that you can actually manage on your own. You don't have to be dependent on others for it.
Yeah, you
You
have
have
all
better
the
art. Yeah, you have
components.
all the components, the elements in place. So, okay, so Gagan Arora, I think from even from the past episode, has been making this point about whether the Indian Armed Forces or security setup readiness. When he's asking what is the Indian Armed Forces or security setup readiness on the cyber electronic warfare and space domain, basically on the new domain, cyber EMS and space domain warfare. I can only say that it is not what has already been achieved by the Chinese, and this is an area that we really need to move forward on quickly. We'll have a dedicated episode on on this,
Each of
on
these.
cyber EMS, yeah, and space as well. Space will have many episodes. Cyber EMS will obviously not talk much and won't go into details because it's highly sensitive, and we should have a dedicated episode on that.
No. Okay. Looks like he's stuck. Let him come back. Um, okay. Yeah. So, like he was saying, right? So, we will have an episode on all of these. Space is long pending, so we'll do that very soon. Um, okay, Aditya, no one has asked the usual question on Prahar. Um, yeah, I think it's a question of doctrine, having to fix up the doctrine first before we come back to orders. So unless that is finalized, I don't think we'll see orders yet. Or maybe the army had wanted the Pranash, right? So longer 200-kilometer range. So once that happens, then maybe yes, we might get orders there. uh, DZ Propulsion in an interview said they want to move to turbofans in the future. Do you think possible? Uh, yeah, the smaller turbofan market is actually wide open. Turbojet turbofan. We are going to see a lot of these loyal wingman type platforms with multiple sizes. He's back.
It's
Yeah. So,
incredible that the moment I mentioned
cyber. Oh man.
electromagnetic,
Yeah.
that is the point at which things went blank. Uh,
No, I was
I
asking
have
the
a
next
yeah,
question on
yeah.
DG Propulsion's intent to move
Okay,
to turbofans. So all
okay.
of these unmanned loyal wingman drone programs will require turbofans of the smaller turbojets and turbofans of the smaller size,
I'm not
1 kilonewton or so.
turbojets at all. Yeah,
Yeah,
yeah.
so
Okay.
then yeah, they are looking at a huge market. provided the government actually gets cracking on that unmanned loyal wingman manned unmanned teaming whole side of things. I think the Air Force and the MOD have to push for it, but first we need doctrine for that. I'm hearing from a few people that it is being worked on. So once you have doctrine and concept of operations, then you will have we touched upon this exact same thing the previous episode or the one before that. Unless you have intent and you have clarity of vision on what you want to do with your armed forces, then that will drive design of your arms. I think it was when we were chatting with Brigadier Rathore. Right? So once the doctrine and concept of operations, ConOps as they call it, that is clear, then you will have platforms being designed around it, and that will drive your engine needs. So yeah, I mean, there are 2 3 small engine companies who are in this space at various levels, and once there is greater clarity on what the platform needs to accomplish, you can make engines accordingly. And they all seem to have multiple engines around multiple thrust levels, so it should happen because these will be ordered in the hundreds. So there is a good business case for it.
No, thousands, thousands.
I'm talking in the Indian context. I'm keeping my expectations low.
You're managing expectations already.
Yeah,
Yeah, that is.
trying
I
not to
agree with
get
that.
disappointed.
Yeah, but I can say one thing that, see, it's when you talk about a small sort of less than 12 kilonewton system, going from a turbojet to a turbofan will not be that difficult. Okay, it's not such a big deal either. And ultimately, a turbofan, the code is a turbojet only. You have a turbofan, you have a large fan added in front, and you have bypass ducts, etc. There are bespoke materials that are used in the bypass duct and all that, but that matters less when you're talking about a small expendable system. So I'm sure they'll be able to go to turbofans. Whether they'll be able to scale up to the 50, 25 kilonewton, 50 kilonewton turbofan, that's a different matter. In fact, I think the time has come for DDR to sort of interact more closely with DG propulsion, because we must give respect to people where it is due. Here is a gutsy enterprise that is actually trying to do things from the ground up, and is quite open about what it is doing. I mean, it is sort of has it's crowdsourcing sentiment almost, because it puts out the daily challenges that they are facing and stuff like that, and one has to respect that, really. So from a startup, they need support, they should be given support, and if they keep at it, over time they will come up with things which will matter, because what has happened is the industrial supply chain today, the ecosystem, is not what it was 20 years ago. Okay, as far as fourth generation turbofans are concerned, fourth generation fighter class turbofans, you essentially can make them in India. It's not a big deal. You have all the elements in place, and there are all these clumps of expertise with various private and public sector enterprises on the manufacturing side, which is relevant to the development and subsequent production of a fourth generation engine, which is why this Kaveri derivative engine is going to go forward. That is going to see rate production at some point, is my view, right? Just like the Manik will see rate production. That is, of course, an expendable engine, a 4 kilonewton expendable turbofan for cruise missiles and other similar systems. So we have moved forward in that sense, but the thing is, somebody has to take the leap of faith. First of all, we need to work on fifth generation engines. Those have particular characteristics, OPR, FPR, all those things are different for a fifth generation engine, right? It is also something where the core temperatures are obviously much higher, because that relates to what I just mentioned. It's order of 1900K and above, 2050K. Then there is the larger issue of us attaining capability in ceramic matrix composites. You see, GE has been working on ceramic matrix composites for years and years, in fact,
35
decades, if
years
you
easily.
take initial, yeah. So, and today they are in a position to put CMCs in many parts of the engine, including the low pressure turbine, right? So, the low pressure turbine NGVs, they can put, and in fact, they are moving even beyond that. So that, and it's all silicon carbide essentially. So we need to move there quickly. So even as we work on the fifth generation engine, We will also have to work on sixth generation engine technologies. What leads to things like the XA 100 basically, right? Which is going to be it was designed as a drop-in replacement for the F-35's current engine. And that's a three-stream engine. That's a variable cycle engine. There's a three-stream engine over there with an adaptive bypass ratio. So that is where we need to go. Now, what are the paths in which we can go? In which we can head there. One would be entering into an arrangement with a foreign entity that I have also been a proponent of for the fifth generation effort. Another would be in perfecting fourth generation engines on the side also. So if you have to run multiple programs, it is going to cost money, but the returns will be more than commensurate. Okay, because by any estimate, we are going to import some 60 to 80 billion dollars worth of just engines by the 2040. Those are the current numbers, right? So I mean, the number is going to go up quite a bit because if you add all the civilian engines also into the mix, the number is going to be considerably
Civilian numbers will
larger,
be huge.
huge, massive. So, and once you perfect a low bypass turbofan, you can always move to a high bypass turbofan. There can be any number of spin-offs from a low bypass turbofan. You can get your own turbo shaft of a different variety. You can even get a turboprop, right? You can get a marine gas turbine. You can get industrial gas turbines also from it,
Yeah, right
and
now
so on.
all of
Yeah.
the BHEL industrial power generation happens from using General Electric industrial gas turbines. So
Yeah,
yeah,
and,
that's a
and
huge
so
market.
so yeah. This is a key technology. While people talk about AI and other general purpose technologies, all that is important, no doubt. And if you go by what is going on in the world, they will say those are the defining technologies of our time. But this is actually the defining technology: jet engine propulsion. Right? This is going to really matter more than anything else. And it's also going to matter because even those AI systems that you want to put on board the platforms of tomorrow, those will be power hungry, and those will require electrical power. And that is why you need the jet engines of tomorrow, which can also sort of cater to that kind of load apart from propelling the platform itself. So there are this is the crown jewel of manufacturing technology, and this is what this country has to focus on. Because if you get there, and this country is better or does things better when there is technology denial and there is a clear objective. Okay, we have to get here. There's nothing doing. We'll get here one way or the other. Then you can have proper, you can even manage inter-party political buy-in for something like this, as long as somebody doesn't try to take unilateral credit for it. So if that can be managed, then this is the kind of program that you need to focus on. You need to perfect fourth generation engine technology and produce it in numbers, because the same issue happens. You just jump to the fifth generation engine. If it takes 10 years to develop and you don't produce fourth generation engines in the interim, then you won't have a ready supply chain for the fifth generation engine. You will be dependent on that foreign OEM that you have partnered with, basically, because that foreign OEM obviously has fourth generation engines which are being produced at rate right now, right? Whether it be the French or the
So it makes sense
or the
to
Americans or
continue
Britishers.
production and
Yeah,
make money. Make
yeah.
money.
So you should definitely perfect fourth generation engine technology and build it in numbers. And the one that you can build is obviously the Kaveri derivative engine, and you must also have flight worthy Kaveri engines ready, baseline Kaveri engines ready. Integrate that with the Tejas trainers as has been proposed, and get a whole load of flight data, very valuable flight data. There is no substitute for data in this realm, as there isn't in many other realms
Yeah, if you
also.
want to build your own fifth and sixth generation engines directly, you still need all of that data to base your
Yeah,
next gen design on.
yeah, absolutely. So limited envelope testing has to be done on the Tejas with the Kaveri sooner than later. Kaveri derivative engine must be produced in numbers. Manik will, I'm sure, I hope, will be produced in numbers. All by all accounts, it will be. These things will create a ready supply chain for you as you work through the fifth generation engine. As you work on the fifth generation engine, these will also help you with with contingencies. If contingencies arise and you're suddenly denied a whole bunch of engines, and you need to maintain and refurbish whatever engines that are already there, you will be able to do it via the supply chain. right? Say so tomorrow the Americans sanction us, and we are stranded with maybe 150 odd F404s and some 99 F414s only. What do you do then? That is when the supply chain will matter, because that'll be crunch time. And see, even the best engines in the world, say let's say GE's engines, F404, F414, you're going to need at least two and a half to three of those through the life cycle of a Tejas fighter. Okay, you're not going to be able to do with one or one and a half, as it were. You will have to have two and a half to three. So one more thing you can do is you can start, obviously F414. You are trying to get into an arrangement for license production. I think the license production should be a long run for that if you're getting into it. F404 also, those options should be explored, or at least buy a whole bunch of F404s right now and keep them.
Yeah.
Because
Yeah.
yeah,
Hey,
uh,
I think we can do another engines episode. Yeah, maybe
yeah.
next one.
No, this
Talk
is
about
like
all
a
of
this is
these issues.
engines are like an emotion for DDR, right? So we
Yeah,
once
once you
we
get
get into
started, you
it,
keep
yeah, we
talking
just
about
keep rambling on it. Yeah.
it.
So
Quick thanks to Aditya Saragi and Rishabh again for your very generous contribution. Thank you so much. Before I come to your question, Rishabh, I think we'll stop there. But one question: can you explain how Pralay, Pranash, Prahar differ from each other? Pralay is a big missile, right? 1 ton warhead which can hit 300 kilometers away. The Prahar is a smaller rocket, right? The range is much lower. The Pranash is something that the DRDO offered when the army said they want something uh, slightly with a greater range. But nothing ever came out of it, even though they proposed these options. But yeah, hopefully, maybe once decision makers get serious about the rocket force and uh, they want something, or maybe some other conflict comes up in the high mountains, maybe it'll happen. Who knows? You have any insight into the Prahar family?
well, Prahar is derived from the AAD, right? And that was supposed to be the big one of the big cells of the Prahar was that because it is
Commonality.
so yeah, it is yeah, commonality with the AAD, and if you entered into rate production of both, you will have great economies of scale. And I mean, in the case of the Prahar, you would have, by all accounts, a fiber optic guided gyro only, right? A fiber optic gyro based INS.
Yeah.
You don't need anything more than that for an artillery rocket like this. There will be a bunch of people who will say, will the Pahar get intercepted in today's time, given its terminal velocity and its trajectory and all that. The whole idea is that even if some of them get intercepted, many will get through. You need
Yeah,
to
it is a mass weapon
build it in
anyway.
numbers. Yeah, exactly. But it could be quite accurate also, even with the FOG based guidance system. Pranash, as
Anyway.
you mentioned, it's an extended range system over the baseline Prahar. I mean, it's supposed to be out to 250 kilometer. That's been reported anyway. Pralay, as you mentioned, is a much bigger. It's a much heavier system. 400, 500 kilometers, warhead, 800, almost 800 kgs, and
Yeah.
but a range of munitions are possible. And the range, of course, will vary with the warhead size, as is the case with all ballistics. So that will be there,
Yeah.
but it's also a guided system. I mean, it can be a guided system. It has an INS anyway, but it can have a front end seeker as well. So
Uh,
it's
yeah.
highly contemporary. Yeah.
Let's say
So
next
that is
question
there.
from Rishabh, and let's wrap up here. It's
Yeah.
getting pretty late.
Pretty
Status
late.
of
Yeah.
ramjet and bleed munitions for ATAGs. Was the demand for this from the army side, or will they become very costly for us in large numbers? Great work. Thank you so much. The ramjet shell that IIT Madras was working on under the ex DG artillery
General
Lieutenant
Shankar.
General
Yes. Yes.
Shankar.
Yeah.
Apparently, they've. I mean, by his own words, I think during an interview or something, he said they'd gone for firing trials at Dale Ali, if I'm not wrong, the army
Mm.
firing range, and
Yeah. Yeah.
they've
Near
come back
Nasik.
with some data, and they have more work to do. There's still quite a bit of work to be done.
But
I don't
there
think
is
the
yeah.
ramjet engine was ever turned on. I think they just did firing trials. So
Yeah,
you
yeah,
might.
there are a whole bunch of issues before you actually test the ramjet itself.
Yeah.
Somebody asked me whether you can have a scramjet based munition also. You can't really from a 155 millimeter artillery
You need to hit Mark 3.
gun. Yeah, you need to know. You need to hit more than that. You need to hit
No,
at
at
least
least if
Mark
you have
4.
a DMR, dual mode ramjet.
Yeah, yeah. DMRJ maybe, but that's a maybe even then because
That's a
see,
tougher technical challenge on
right,
a
exactly.
artillery shell
Exactly. On
sized
an artillery
article.
shell, on the form factor of a 155 millimeter shell.
Yeah.
So see, when the fastest that you the highest muzzle velocity that you attain is 950 965 meter per second. Okay, and that is the velocity of the shell when it is leaving the barrel. See, unlike a rocket which gains speed over time, a shell will only slow down over
Yeah,
time,
it's
right?
just ballistic.
Uh,
All the
yeah.
impulse
So the thing
comes
is,
in the barrel.
yeah, so the first impulse is all that matters. So you are never going to get to a point where you will be able to
It accelerates.
even the speed is there. You won't get scramjet initiation anyway. And oh yeah, all this is, I mean, what will be the point also with scramjet initiation? The point would be greater range, right? Or even or faster terminal velocity. These two will be the points. It's just too much of a challenge to
Artillery
achieve
shell
with.
flying in
Yeah,
itself is fast
yeah.
enough.
Yeah, so the
Imagine
thing is that
50
yeah,
kilometers. Okay, assume 70 kilometers with a scramjet at Mach 5. Mach 5 is 330 times 5, 1.6 kilometers per second. You hit 70 kilometers in 5 seconds. Shoot and scoot, I guess.
if
Whatever.
somebody is crazy enough to make it, I would be happy to see it. If it
No,
is
it's
at
too
all,
much
I
of a
don't.
technical challenge. I don't think
It's
it's
not.
worth
Yeah,
the money putting
yeah.
in.
It's
Putting
not.
in.
It's not. It's not.
Yeah.
It doesn't. It
Okay.
doesn't work that way.
Yeah.
Yeah.
Maybe last question. What is the status of the forge press that is being talked about? Talks are on. Um, funding, and then it'll happen. It's a lot
It
of money.
has to happen
800 to
without
1000
the
crores.
without the closed eye hydraulic press, you can't really make the
And without
NCA
that, no
numbers.
AMCA, no next gen engine. Even
Yeah.
the Kaveri full rate production for that matter.
So anyway, so this has been so we come to the close of yet another episode of Indigenization Appreciation Hour. I hope you gained a few insights from our rambling about rocket artillery systems, and we are going to bring this to a close today. Sorry for the delayed sort of start, but there was an emergency. If you believe that emergencies can happen on Sundays, but it did
At
happen,
10 o'clock.
and yeah, so that had to be sort of mitigated before we could do this program. Anyway, thank you for joining,
Yeah.
and
Thanks
as
for your
always, Jai
contributions.
Hind. Thanks
Yeah.
for your contributions, Jai Hind. We'll come back with more next week. Right.
Yeah. Bye bye.